Hello and welcome everyone to our first video interview in the series of Research Spotlight interviews with prominent researchers who are using eye tracking technology across a broad range of applications and research fields, but with a common ambition of making a positive impact on society. And today I have the honor to talk with Dr. Karen Pierce, a professor from the Department of Neurosciences at the University of California, San Diego, a renowned expert on autism who has dedicated the past more than 25 years to studying this condition. Welcome, Karen.
Thank you so much. And really, it's an honor to be here. I've been using Tobii technology for a really long time, and so I'm excited to get the chance to share all the work and discoveries I've made using eye tracking. So thank you.
Thank you for accepting this opportunity. It is really a great joy for me to have the opportunity to speak with you about your work and delve a bit deeper and try to understand it a bit deeper. So I've decided at the beginning not to read the summary of your bio, since it will most likely misrepresent or understate the value of your work. But I would like the beginning of our conversation, in the beginning, to ask you some questions that would actually allow those who don't know you to get to know your work better. And I'm sure that all of those hearing us who are from the autism community would already know quite a lot about you and your work. But since we are addressing a bit of a broader audience of mostly those who are united in being interested in behavioral research and eye tracking technology, let's start from the very beginning and establish a common ground for everyone. And then I have to start with a question of what is autism or autism spectrum disorder? How would you define it?
Yeah, autism spectrum disorder is a condition that impacts how a child perceives and reacts to their social world. They really, at its core, it's a condition that impacts a child's ability to socially interact in a way that's naturalistic, that's going to generate a lot of connections with other people. So, for example, you might be talking with a child with autism and you'll notice something big happens to the side, and you'll turn your gaze and look at that. And a typically developing child will be like, hey, what is Karen looking at? And they'll turn their gaze as well to get this shared content. But a child with autism might miss that and might not do that. They might have unusual eye contact, so they might not use eye contact in a typical manner. It might be reduced. They just might come across as having just more challenges with entering groups. So it's really a social issue. It's also a condition that impacts someone's interests. A lot of individuals on the spectrum have what we call restricted and repetitive interests. So they might be focused intensely on one thing, like I knew somebody who really loved maps and train schedules. And every time that you would talk with him, he would just bring the conversation back to maps and train schedules. And it was, it's fun, but it's really hard to develop deep social relationships when the interests are restricted. But also the important thing to know about autism too is there's a lot of heterogeneity. So by that, I mean that it's heterogeneous in terms of the symptom profile, like how people present clinically. So some individuals with autism might be extremely impacted and might not even speak, right? They might be completely nonverbal. Whereas other individuals, they might actually go off and get a college degree, and yet they have the same diagnostic label. And so it's really this unique and interesting combination of these social challenges along with these restricted interests that make up autism. But again, when you're thinking about autism, it's like a very wide range of individuals in terms of how their autism is manifesting in them.
Mm-hmm. Yeah. But what has inspired you to first start with this topic of autism?
That's actually a great question. I was an undergraduate at Stony Brook University, and like all undergraduates, I just wanted to get an easy A, right? I wanted high grades, and my roommate said, why don't you do this research assistantship? You get a grade for it. It's working with kids that have some issue, but she didn't really know what it was. So I showed up the first day, and it turns out it was a research lab for children with autism who were completely nonverbal and had a lot of difficulties unfortunately, managing. They were 16 and really hadn't been able to speak for their entire life. So there were some aggression issues. And I, started on my first day, and we went to an ice cream shop called Friendly's. It's something on the East Coast in New York. We were giving this child, George, he's not a child, he was 16, a reward because he went the whole week and he did a great job at school. He didn't, show any signs of aggression with anyone. He didn't hurt anyone, and everybody was so proud of him. So George and I went up to the front of the ice cream kind of whatever, like the glass case of all the ice creams. We're both just kind of looking at it, and then all of a sudden he turned around and he punched me in the face, and I really was knocked out for like a few seconds. I was just lying on the ground, and I just was so, I got up and ran into the bathroom, and then everybody was like, "Oh, she's never going to come back." But I did come back because I was like, this is, I can't believe that what the pain that he must be feeling to not be able to communicate. He probably was super excited about the ice cream. I mean, I was too. And he wanted to get my attention to tell him maybe what flavor he wanted, like who knows. But it was clear to me that it was an excitement and a wanting to actually connect, not, anything else. And so I was just really fascinated. I was just determined to figure out what was going on with him, to do what I could to try to help him and other kids. And so I started my early career in treatment of autism. And then I was like, wow, I love this. I'm going to get a PhD. So I got a PhD in treatment related fields, applied behavior analysis. And then I realized, autism is definitely genetic, is a strong, we know monozygotic twins concordance is 90%. It's a disorder that impacts how the brain functions. And so I really need to understand the neurobiology and the kind of more of the basic science related to autism and not just jump into treatment. So I went back and essentially got almost a second PhD. I respecialized in neuroscience, and I took classes with medical students and did stuff like that. So I kind of went full circle, starting out in the treatment world. And then I went and did a lot of brain imaging. And then I moved into eye tracking. And now I'm starting to think about going back into treatment to use maybe some of the things I've learned to optimize treatment profiles or treatment plans.
Yeah, that is very admirable. It is obvious that there is a big passion in understanding the disorder and also helping the individuals in all the ways possible. But what would you define as a vision of your career and the research that you're doing?
Moving forward, like what do I hope for? Well, my goal for my research is to discover early biomarkers of autism so that every child can reach their full potential. I hope that it's going to be standard of care that most children with autism are identified between 12 and 24 months. It's just going to be standard. We are getting better at identifying children at younger and younger ages, but the Centers for Disease Control, which tracks prevalence rates, shows us that the median age of first diagnosis is still around 45 to 50 months, 52 months. So a little bit over age 4 for most children throughout the country, which, I think is too late. I think that there is a chance that there could be some really nice positive improvements if we detect early and treat early. So my vision is to discover early biomarkers to get these kids in treatment as quickly as possible. And another vision is really to move the research into a place where we're moving towards precision medicine. Because right now, when you go and get treatment, it's sort of a one-size-fits-all model. A lot of treatment agencies are obviously trying their best and they're doing a great job, and they do try to tailor to each individual child, but they're going about it blind. Like they don't really know a lot about the child's underlying biology when they start their treatment protocols. And so to the degree that we can start providing them a little bit of a roadmap about something special and unique about each child before somebody starts the treatment protocols, then maybe we might be able to even get greater gains out of treatment than currently exist.
Amazing. Yes, that sounds very inspiring. Is there something you would personally highlight as the main finding of your work so far?
Yes, I would say that the main finding of my work so far is that, as I had mentioned earlier, autism is very heterogeneous, right? There's some kids have really severe eye gaze patterns, and some kids don't talk, but some do. And that eye tracking, I believe, can be used to diagnose autism at young ages and with high accuracy. However, I've developed lots of different eye tracking tests because of all of this, heterogeneity in autism. It's not really the case, and it's unrealistic to expect that a single, 1 or 2 minute eye tracking test is going to be able to diagnose everyone with autism accurately because everybody is so different. So the biggest finding of my work is that eye tracking can be used to define subtypes of autism and diagnose with very high accuracy different subsets of kids. Like, for example, I've developed some eye tracking tests that don't have any sound at all. It's just visual. And we're figuring out, like, okay, what does the child like to look at? And based on proportions of what they like to look at, and also the saccade patterns, the positive predictive value of them actually truly having autism based on what a licensed psychologist might say, or based on the diagnosis a licensed psychologist gave them. The psychologist is, of course, blind to the eye tracking results. It's extremely high. Our studies show that it's between 81 and 100%. So that's
Mm-hmm.
really high positive predictive value. But the sensitivity of any single one of my eye tracking tests is on the lower side, around 20%. That means that only 1 in 5 children with autism will quote unquote fail or show abnormal or unusual eye gaze patterns
Mm-hmm.
in response to some of these eye tracking tests that I've been developing. And that's, again, because of all this heterogeneity. But it's also, I think what's cool is that it offers a great opportunity, because with eye tracking, you can see which children with autism are having the most challenges, but you can also see which children with autism are not and are
Mm-hmm.
actually showing really good visual attention. And those are the kids that you would make predictions are going to actually probably have a slightly better time in
Yeah.
school, and they're the ones who are going to go after college and get the jobs and everything like that. And so eye tracking is really telling us quite a bit, I think, not just about diagnosis, but also potentially about prognosis and outcomes.
Mm-hmm. Amazing. Yeah. So this leads me to the second topic that I would like us to touch upon, which is technology. And I'm personally fascinated by how limiting it can be in one's research. Of you can only answer those questions that you can actually measure the effects of currently with the technology that exists today. But on the other hand, the technology is being rapidly and constantly developed and in this way it opens new opportunities to examine something that was not possible prior. And since you have a very rich experience with your research, maybe you could reflect a bit on that and tell me, as someone who doesn't have as much experience or much less, how has your journey with technology been?
Well, I actually have used a couple of different types of technology, and my journey with the eye tracking technology itself has been great. One thing I love about Tobii is it's very user friendly. It's great for me because we have lots of students that work in our center, and we want to give them the opportunity to participate more directly in research. And because the Tobii is so user friendly, we obviously have a pretty rigorous training protocol, and we don't let anybody just collect eye tracking data, but we do select students that seem like they might be a good fit, and we go through some training and reliability and everything. But once they pass a certain bar, then undergraduate students get to collect eye tracking data, which is amazing, and it really wouldn't probably be possible with other systems that might be more challenging to use. So it really provides a lot of direct access, I think, for a lot of different people, which I really like. And also, I do a lot of brain imaging research as well. And so we've been able to look for relationships between brain function and eye gaze patterns in children with autism. So we have this synergistic kind of dynamic going on between two major technologies. And we've been really finding some interesting things. For example, well, I guess I can just kind of take a step back. And if you think about eye tracking, right, it's an indirect measure of how the child might attend to things in their real world, right? Eye tracking is just a proxy for maybe how the child would do when they're not on the eye tracking machine. But you can make the inference that a child that's looking at unusual things when they're watching a scene of children playing together, maybe in real life, they might also be looking at unusual things, right? And we talked earlier about the fact that the brain is very plastic during early development, and the brain feeds itself by environmental input. What you put into your brain is going to establish what connections are made and what connections might die away. And so we basically did an experiment where we had children with autism doing one of our experiments. It was actually a Mother-E's eye tracking experiment where we use gaze contingent technology. And if a child looked at one place on the screen, they would hear an actress, speaking in baby talk, like, "Oh, sweetie, you're so adorable. I love you." And if they look somewhere else on the screen, they might see something non-social, like cars honking on traffic, like a busy highway. And then we took those same kids and we had them participate in a sleep fMRI study where we bring them to the brain scanner during natural sleep, put on some headphones, and we pumped in the same sounds that they heard during the Mother-E's eye tracking paradigm and checked to see, okay, what's going on in terms of their brain function. And we found that the children that did actually a great job during the eye tracking paradigm, they looked at the actress, they were engaged, they had higher levels of brain activation in the superior temporal gyrus and the superior temporal sulcus, which are essentially brain regions involved in speech processing and emotion processing, than the children with autism who didn't look at this actress, who didn't want to hear the baby talk, the mothery speech. When you
Hmm.
looked at their brain activation levels, they were very low. And so there's sort of this indirect validation that eye tracking really is telling us something powerful and important, and it's associated with how the brain is developing. Now, that's obviously an inference. You can't say that directly, but we are seeing clear associations between more typical eye gaze patterns, better brain functional activation, poor eye gaze patterns or unusual eye gaze patterns, and much reduced brain activation.
Well, this is a very nice example of combining the two technologies and seeing the different aspects that they can actually highlight or show us. And how would you say that your work has benefited from employing eye tracking in your experiments?
Well, like I said, we like to do multidisciplinary work. And so I think it's just adding another layer of understanding because, as I told you, I started off, as a treatment person, clinical, I was trained on the ADOS and all these different clinical tests. And so I could have done my entire career just looking at the clinical phenotype of autism, just, doing early diagnoses behaviorally. But what's great is that when you combine eye tracking, let's say, even just with clinical data, you're starting to see relationships there. So in that example where I said about the children who had unusual eye gaze patterns and then reduced brain connectivity, we're also seeing a reduction in their language ability based on standardized tests. We're seeing an
Hmm.
increase in their autism symptoms based on autism related tests. We're seeing a reduction in social abilities based on parent report measures like the Vineland, as well as during your free play measure when you're videotaping them interacting with their parents. And so it has, really nice sort of face validity, essentially, the eye tracking measure. And so it's really added richness to my research because I can combine it with other things and it really deepens the interpretation of the results.
Yeah. Yeah, so you've already touched upon this. What I wanted to ask, and and the question was, what do we know about visual attention in individuals on the spectrum? You have already indirectly explained that they then typically have non-typical visual behavior or gaze behavior, but you've also mentioned that the specificity of the diagnosing tests that you have created is quite low, meaning that many are actually showing similar visual attention to what would be a typical population.
Yeah, it's actually the sensitivity that's quite low. The specificity is actually quite high. So specificity is a
Sorry.
true negative. So specificity actually for the eye tracking test is about 98%, which is extremely high. That means that if you are typically developing, or let's say you just have a language delay, you have something else that's not autism, the chances that you're going to pass this test is extremely high. So 98%. Like children who don't have autism generally
Mhm.
do not fail this test or any of the eye tracking tests. However, as you pointed out, some kids with autism actually do great and they do pass it. So, what we need to work on really more is the sensitivity, the power of eye tracking to detect all the individuals on the spectrum, those individuals that are going to go off to college and really maximize their potential versus the other kids that are going to struggle more and have more challenges. Right now, the eye tracking is great at detecting the kids that have more severe challenges. The kids that are doing are much stronger in their skills and abilities are not as readily picked up by autism by the eye tracking at this time. But we are working towards developing more novel paradigms that can increase the sensitivity of the eye tracking.
Mhm. So still with the eye tracking technology.
Yeah, still with eye tracking technology.
Okay. And so here you have already mentioned that this series of articles that I have seen recently, where you are actually describing this diagnosis tests with eye tracking and with the help of eye tracking. Would you like to tell us a bit more about this full body of work and where it is at right now and what the next steps are?
Yeah, so that's a really great question. Kind of the full body of my eye tracking work is probably my first publication was around in 2011, so a little bit over a decade now. And I started out with a visual only eye tracking test called what we call the GeoPref test. It's basically a preferential looking paradigm, and a child either looks at children, essentially they're doing yoga, but it looks like they're just jumping around, and then the other side of the screen shows these repetitive shapes, these repetitive geometric shapes. And we discovered pretty early on that around 20% of children with autism really like to look at the geometric shapes. They're looking at it 69 to 100% of the time. They're ignoring the kids. And when they do that, the positive predictive value, my first study was actually 100%. So, if a child did that, then they ended up with autism. So then after that, we wanted to just check, well, maybe it's something specific about those stimuli, and it's not, something foundational to autism. So we designed a new study where we changed it up, and we had different social scenes and ran the test again, found the same thing. So we've done it a couple of times just looking at visual only. And then I really, understood that children with autism sometimes have speech issues, speech processing issues, as well as expressive speech issues. So I was trying to think, how can I leverage eye tracking to get at what, a more of an auditory processing thing, not just visual. So I decided to use gaze contingent technology, which basically just means that you set up the eye tracking system, usually in combination with other software such as ePrime, that allows the child to control the experiment themselves. So the child's gaze fixation, the XY coordinate, triggers whatever it is they're going to see or hear. So in my most recent paper that was published in JAMA Network Open just about a month ago, showed a similar phenomenon to what some of these visual only tests did. And that is a small percentage of kids, 20 to 30%, depending on the paradigm, will prefer to listen to these traffic noises or listen to musical notes rather than listening to human speech, rather than listening to this motherese. And you can use that to accurately diagnostically classify. So almost all of my papers, are around 5 at this point, really drive home this point that there's really there's high diagnostic accuracy, but modest sensitivity for one test alone. So we're starting to combine them. And my research also shows that there is this really robust relationship with clinical phenotype and symptom severity. So the children, again, that are doing great on eye tracking, they tend to be doing better. Their language is better, their social skills are better, their cognitive skills are better than the children that are not doing as well with eye tracking. They are the ones that have the more challenges with speech and socialization. So it's nice because eye tracking is a quick proxy. You can do eye tracking in 10 minutes. You can do an entire test battery and really know something about that child without the hours and hours of standardized testing from a licensed clinical psychologist that you may or may not be able to find. And so it really has that nice benefit of telling you something about the child's clinical profile.
And when we think about the practical application, could I imagine that in future that pediatricians' offices would be equipped with eye tracking and such diagnostic tests, and that they could readily use them early on?
I hope so. That's, we've been working on this for a really long time. So that's definitely one of the goals. I mean, imagine, the thing about autism during early development, during 12 months, 18 months, 24 months, it's really hard in a 5 or 10 minute pediatric visit to know, is this child struggling maybe just with a language delay or a global developmental delay, or is it really autism? Pediatricians are amazing, but even an experienced licensed psychologist would have a hard time in 5 or 10 minutes figuring that out. And so what's nice is it empowers pediatricians. They've got a tool. They can, if a mom is like, I'm concerned, my child's really not talking, or my child is not making great eye contact, or he or she is always avoiding other children, I'm worried, the pediatrician can be like, okay, go down the hall, take this test. And we can start to develop that technology so families can get some information pretty quickly. And then that could potentially be used to guide. Maybe they might want to go and get a diagnosis from a licensed psychologist, or maybe they might just say, I'm going straight into treatment because I know that there's a lot of research to show that if my child has this particular eye gaze patterns, extremely high chance that they have autism, and I don't want to waste any time. Mm-hmm. Because the great thing is that a lot of these, or all of these treatments for autism, are behaviorally based. They're very naturalistic and very play-based at this point. And so it's really not, it doesn't, really, it's not going to hurt anybody to just go straight into treatment, because it's just a fun time playing around with toys.
Mm-hmm. And why has it typically taken so long to be officially diagnosed with autism? So officially, or typically, it is around the 3rd year of age, as far as I understand, that the diagnosis actually takes place, although the symptoms are visible very early on.
Yeah, I think that's a great question. And again, the CDC report states 52 months, so a little bit over age 4 years. That's a national average. Certainly in
Mhm.
places like San Diego, it's way earlier because we're just a hotbed of research and we have a lot of clinical resources. But in other places in the country, they may not have that. But circling back, why? It's not only that it's observable at early ages, it turns out that there's a lot of research that shows that autism most likely begins in the womb. So when a mom is pregnant, the child is already on their way to developing autism. And so it's pretty much there from birth. And so why is it taking so long? And that is a really good question. Um, I think it's a complicated answer. One is that, during the first few months of life, obviously babies aren't speaking, they're not socially interacting. They're
Mhm.
doing a lot of things that are more for basic survival. Like they want to get fed, they want to be held. They're sleeping enormous amounts during the day. So it's not quite as easy to notice if something's going wrong. However, by the time they turn one, that's why I'm so focused on the first birthday. I think like I would love it if we could figure out autism on the first birthday for everybody. That's when they're first starting to talk. That's when they're first starting to walk. They're not doing complex attention behaviors at that point, but they're starting to be able to do these precursor joint attention kinds of behaviors, like noticing
Mhm.
when someone has a different gaze, or if you point, they might start to follow your point. That's really more like 15 or 16 months. But the point is, they're doing so many more complicated things between the first and second birthday that we can start to more readily pick it up. And the reason maybe that it's not until 3 or 4 is that there's not a lot of resources, first of all. Second of all, very often people will say, oh, kind of wait and see. It's really hard to make the call. And so
Mhm.
people, I think, are just sort of giving the child a little bit more of the benefit of the doubt and thinking there's a lot of variation in early development, and so they're just sort of waiting. And again, there's just not that many places that you can go that
Mhm.
have people who are really specialized, and so it's usually just sort of like a mounting urgency that eventually happens, and then then the parents will take the child somewhere to get an evaluation. But it's a gradual urgency, I think, that builds up.
Mhm. And it is essentially within that period of 1 year to 3, 4 that not engaging in joint attention, for example, can be detrimental to language learning, or it is then definitely influencing that the child is not learning as much as a typically developing child would.
Exactly. I mean, that's how typically developing children learn language. They're merging their attention with someone else. They're having conversations, back and forth reciprocity. That's why motherly speech and just having the child pay attention to the socially animated speech is so important. There are studies showing that children that have more exposure and more attention to motherly speech end up with better language later.
Yeah.
So having this face-to-face language input and reciprocity is really key. And also, having this merge of attention socially to things in the world. So you can have this triangle of attention between a child, a parent, and an object on the outside where you're both looking at the same thing, looking back at each other. That's how you start to learn about the world. And so it's
Yeah,
really critical.
yeah, definitely. Um, Yes, there is one more question, since I believe we do have some time that I wanted to ask you, and that is
Mhm.
this information that the number of children diagnosed with autism has been rising steadily in the past decades, and that it has been also rising abruptly, which is quite striking, and which is a piece of information that I don't necessarily understand. So I wanted to ask you what lies behind this rapidly growing number of children who are diagnosed with autism.
Yeah, I mean that's a really excellent question. My feeling about why the prevalence has increased dramatically is that it has a lot to do with modern digitization and modern record keeping as one primary thing. I mean, when I started in the field, the rates of autism were 1 in 500. Today, they're 1 in 44. That is a massive difference. But
Mm,
when I started in the field, people were determining prevalence rates by like going into schools and looking at paper records and counting. But back then, whether it's due to stigma or lack of experience, a lot of kids were not diagnosed as autistic. They might have just been diagnosed as having intellectual disability or some cognitive challenge, and they're just labeled in this big lump. And there was no fine grained diagnosis of autism, or not very often. And so that's why the rates were so low. Then, we started having more awareness, and a lot of children started to get their diagnosis, but everything was still on paper. So that's just very hard to track that way. Then all of a sudden, kind of with the digital revolution, everything is now in a database. And so
Mhm.
the way the CDC runs the projects is that they go around and count every single health source and look at digital databases in hospitals, treatment agencies, schools, and can quickly add up how many kids have autism. And so it's just this ease of accounting. I think that's
Mhm.
accounting for a lot of it. Also, awareness, right? We're way more aware. Pediatricians are really engaged in the autism community and trying to help and trying to learn in a much different way than they were, 20 years ago or even 10 years ago. And so I really think it's a combination of awareness and technology. And whether or not there's a third piece of, is there a little something going on, maybe environmentally, that could interact with a child's underlying genetics. There are a lot of people that are doing that kind of research. I don't think the answer is known just yet, but
Mhm.
I'm not willing to say that there's absolutely no chance there could be some interaction with the environment, because I think there possibly could be. But I think the bulk of it really has to do with awareness and better technology.
Okay, so we can essentially interpret it as a positive piece of information.
It's a positive. That's right. Because if you look at it in the bright side, we're now, getting really good at identifying kids that need help and getting them into treatment. And,
Mm.
it used to be that it was almost unheard of for a child to lose their diagnosis when I started in the field. And now a lot of kids are doing really well. Maybe 20% of kids at some point in their life may lose their diagnosis and go on and achieve these milestones that a typically developing child would achieve. And again, back in the day, that was extremely rare. And so I think it probably is a positive thing at some level.
Yeah, great. Good. And to wrap up today, since we do have limited time, after all, I just wanted to say that my aim with the conversation was to showcase you and your work, and also partly to also show what eye tracking technology can do when it's put in the right hands, and what impact it can have to one's research, but also to the whole society with the positive effects that research has. And so maybe to wrap up, just the last question of you now, asking you as an eye tracking expert as well in the meantime, what would you advise those who are considering to adopt this technology? Um, who is it good for, and what is it good for? What can it do for someone?
Well, I think if someone's just thinking about adopting this technology, well, first of all, I think it's good for everyone. I think you can learn a lot based on documenting someone's attention patterns across ages, diagnoses. I think it's a very interesting technology and highly useful. But if you're just starting out, I think that the best advice I can give someone is, when you're developing eye tracking paradigm, make sure that you test it rigorously before you go off deploying it on lots of subjects,
Mm-hmm.
because you can be surprised. I had a few times where I was sure it was like the best eye tracking paradigm ever, and then it totally tanked. And so I'm pretty rigorous about testing all of our paradigms on, 10 typically developing kids and 10 children on the spectrum first, and then tweaking it and going back and optimizing it. And I will definitely tweak paradigms many times. Sometimes they're perfect right out of the gate, sometimes they're not, but you definitely don't want to waste time on something. So like doing that initial testing is extremely important. Understanding the value of getting a good calibration before you move on to doing the eye tracking
Mm-hmm.
is extremely important as a new person, that you may not quite appreciate that, but it's a really important thing. And then I think it's also great to consider how you can look at eye tracking within the context of other data modalities or other data types, and don't just like consider eye tracking in a vacuum. And so I think there's a lot of richness there, again, because I think eye tracking really is a nice proxy for what the child or whoever might be doing and responding in their natural environment. So I think there's a lot of opportunity to leverage eye tracking for a lot of creative experiments.
Great, thank you. That is very nice to hear. So I would
Yeah.
like to thank you very much for your time today, and for taking this time to answer my questions, and with your patience with my questions. Yeah, it has been a joy hearing from you actually about your research, and explaining also the different nuances and personal experience that has inspired you and made you passionate about this particular topic.
Well, thank you. It was really fun. I really appreciate you contacting me, and Yeah, it was a great conversation. Thank you.